A clock falls toward a black hole. Not a spacecraft, not a heroic astronaut, just a clock, small enough to imagine, bright enough to see, drifting through the dark with its hands still moving. At first, nothing about it looks supernatural. It ticks, it flashes, it sends back a thin pulse of light each second, like a heartbeat escaping into space. Then the pulses begin to change. They do not stop all at once. That would be too simple. They stretch. The seconds arrive late. The color drains downward, from white to red, from red to something almost invisible. The clock is still falling. Its own mechanism has not broken. If there were a person beside it, falling with it, they would see the hands move normally. Their blood would not freeze because of some magical boundary. Their thoughts would not suddenly pause. Locally, for a while, physics would feel almost ordinary. But far away, where the universe still has room to breathe, the clock is becoming less and less available. It is not merely getting dimmer, it is being removed from the future we can share. This is the first thing a black hole does to the mind. It makes darkness look like a visual problem, when the real wound is temporal. We want to imagine a black hole as a place, a sphere of absence, a cosmic drain sitting somewhere in space. We picture a hole, and holes are spatial things. They have edges, they have interiors, they are empty where something should be solid. But a black hole is not just a dark object inside the universe. It is a failure of certain futures to exist. The clock keeps falling, and every signal it sends must climb out through warped space-time. Each pulse loses energy in the climb. Each pulse arrives more slowly than the one before. The clock does not announce its disappearance with a final, dramatic flash. It asymptotically fades, its information smeared toward the edge of a boundary that is not a surface, not a wall, not a membrane you could touch. The event horizon is often described as the point where escape velocity exceeds the speed of light. That description is useful, but it is also dangerous if we imagine a rocket merely needing more power. Nothing outruns light. But near a black hole, the deeper issue is not only speed, it is direction. The paths that light can take, the possible routes through space-time, are being tilted inward. What used to count as outward becomes less available. What used to be a choice becomes geometry. At the horizon, the future no longer includes escape. That is why the darkness of a black hole is different from the darkness of a cave or night or the space between stars. Ordinary darkness is a lack of illumination. It can be entered, crossed, lit from within, escaped. A cave is dark until a flame arrives. Night is dark until the planet turns. Empty space is dark until a photon passes through it. A black hole is dark because the routes by which light could return have been erased from the future. And once time enters the picture, the darkness deepens. Not because the black hole becomes blacker, like ink soaking into cloth. Real black holes are often surrounded by violence bright enough to outshine galaxies, disks of gas heated by friction, magnetic fields twisting plasma into jets, matter screaming in X-rays before it disappears. The surroundings can be incandescent. The horizon remains silent. The darkness is not the glow around the trap. It is the trap. Imagine standing far from the black hole, watching the clock fall. You wait for the moment it crosses the horizon. You expect an event, a clean before and after. But relativity denies you that clean moment. The clock's signals keep arriving, delayed and reddened, each one stretched by gravity and by the geometry of time itself. The crossing, from your distant frame, is never delivered as a crisp visual fact. The clock becomes a ghost of increasingly old light, a record that never quite finishes. But the clock itself does not wait forever. This is the fracture. There is no single, universal account of the clock's fall that everyone can translate into ordinary human time. The distant observer says the clock slows near the horizon. The falling observer says the horizon is crossed in finite time. Both descriptions belong to the same universe. Neither is simply an illusion. They are different cuts through space-time, different ways of assigning time to events when gravity has become too strong for common sense to remain sovereign. The black hole is already teaching us that time is not the background music of reality. Time is part of the machinery. And when the machinery bends far enough, darkness stops being something seen and becomes something enforced. Every future-directed path inside the horizon points deeper inward, not because an object pulls on light like a hand, but because space-time has arranged the possibilities that way. The horizon is not where light loses a race. It is where the race has no outward lane. That sentence is easy to hear and almost impossible to feel. So stay with the clock. Picture its face turning slowly redder, not because the clock is aging strangely in its own small frame, but because the light carrying its image is being stretched on the way to you. The wave crests arrive farther apart. Their energy drops. Their rhythm thins. The object does not vanish as a theatrical effect. It becomes unreachable by degrees, as if the universe were increasing the distance between event and witness without moving either in the ordinary sense. What you are watching is not simply an object falling through space. You are watching an event fall out of communicable time. This is why black holes are more disturbing when they are not treated as monsters. Monsters can be opposed. Explosions can be survived or not survived. Catastrophes at least happen somewhere, at some moment, in some shared frame. A black hole does something colder. It exposes that the universe does not owe us a single, human-friendly present. It allows clocks to disagree. It lets one observer finish a journey that another can never watch completed. It turns now from a universal stage into a local arrangement. The old picture is simple. Gravity pulls things in. The deeper picture is worse. Gravity changes what in and future mean. That is the beginning of the descent, not the singularity, not the final unknown at the center. The first destabilization arrives much earlier, at the edge where nothing locally dramatic needs to happen, and yet the causal structure of reality has already turned against return. The clock has not reached a wall. It has reached a place where outward tomorrow has disappeared. The phrase, gravity pulls things in, feels harmless because it matches everything the body has ever known. Drop a stone, and it falls. Spill water, and it seeks the floor. Miss a step, and the ground arrives with brutal certainty. Gravity behaves like a downward command. It makes things heavy. It drags them toward the earth. It gives direction to falling and pressure to standing still. From childhood, the lesson enters the nervous system before it enters thought. Below is where unsupported things go. So when we first hear about black holes, the mind extends that lesson until it becomes monstrous. A black hole must be gravity made extreme, a cosmic weight, a pit so deep that not even light can climb out. This image is not useless. It contains a shadow of the truth, but it also quietly preserves the old comfort. It lets us imagine that the universe still works the way we expect, only with the dial turned beyond anything familiar. More gravity, deeper hole, stronger pull. That is the false comfort. Because if a black hole were only a place where gravity pulls harder, it would still belong to the same intuitive world as falling apples and collapsing buildings. It would be dramatic, but not conceptually dangerous. The rules would remain human. Objects would move through space. Time would tick in the background. Gravity would be a force acting inside an already existing stage. But Einstein's theory took away the stage. Gravity, in general relativity, is not simply an invisible hand tugging matter through space. It is the curvature of space-time itself. Mass and energy do not merely sit inside the universe and pull on other things. They alter the geometry in which motion happens. A planet orbits not because it is constantly being yanked sideways by a mysterious string, but because it is moving as straight as possible through curved space-time. What looks like a force can be the shape of the path. This is the first major betrayal of intuition. The Earth is not pulling the moon through a flat cosmic room. The Earth is helping define the room. For weak gravity, the difference can remain hidden. Newton's picture works beautifully for bridges, tides, falling bodies, and much of celestial mechanics. It is not stupid. It is one of the most successful approximations ever made. That success is part of the trap. The human mind begins to believe that what works locally must be deeply true everywhere. It mistakes a useful map for the territory. Near a black hole, the map catches fire. The black hole does not merely make gravity stronger. It pushes the geometric nature of gravity to a point where the old language starts to fail. Pull becomes too small a word. A pull is something that acts on an object from outside. It implies that there remains a space in which the object could, in principle, resist, turn around, choose a different route, apply enough thrust, escape. It preserves the idea of an arena with forces inside it. But the event horizon is not a place where a force becomes unbeatable. It is a place where the arena has changed. To feel the shift, imagine a river. Far from a waterfall, a fish can swim in any direction. Upstream takes effort. Downstream is easier, but choice remains. Closer to the falls, the current strengthens. There may still be paths back if the fish is fast enough, but at some point, the water itself moves toward the drop faster than the fish can swim against it. The fish is not held by a claw. It is carried by the medium in which all its swimming must occur. The metaphor is imperfect because space-time is not water, and black holes are not literal rivers. But it reveals the important change. The danger is not only an object exerting force. The danger is that the thing you move through has acquired a direction you cannot override. Near a black hole, even light must move through space-time. Light is not outside the rules. It is the speed limit of the rules. And when space-time is curved severely enough, the future paths available to light bend with it. Escape does not fail because light is weak. It fails because the geometry of possible motion no longer contains an outward route. The old comfort says, light tries to leave, but gravity pulls it back. The deeper picture says, after the horizon, leaving is no longer a future-directed path. That difference is the difference between a prison with strong walls and a world in which every road forward points deeper inside. This is where the word hole becomes misleading. A hole suggests an absence carved into something. A hole in the ground, a hole in fabric, a hole in a wall. There is an outside, an edge, an inside, and perhaps a way around. The word gives the mind a shape it can hold. A black hole is not that kind of hole. It is not an empty tunnel bored into space. It is not a spherical mouth waiting to swallow matter. It is a region where space-time has been curved so severely that the causal order of events changes. The horizon does not mark the surface of a material object. It marks a boundary in what can influence what. Outside, light can still reach distant places. Inside, all future-directed motion, even at light speed, remains trapped. That is why adding time makes the darkness worse. If we think only spatially, the black hole is a dark location. If we think temporally, the black hole is a one-way arrangement of futures. The difference is enormous. A dark location might be illuminated. A one-way future cannot be negotiated with. The body resists this because the body was not built for such conditions. It was built in weak gravity, slow motion, low curvature. It evolved inside a narrow regime where clocks mostly agree, space feels stable, and the ground is the most impressive gravitational fact in daily life. Our senses are not wrong in that regime. They are tuned to survive it, but survival intuition is not cosmic truth. The fall of the clock begins with that mismatch. Far away, the clock can be treated almost normally. Its signals arrive once per second. Its motion seems like motion through a container. But near the horizon, the container model decays. The clock's path is not just a trajectory through space. It is a world line through space-time. Its ticking is not happening against a universal background. Its time belongs to its path. This false comfort must be removed before anything deeper can be understood. As long as gravity remains a stronger version of falling down, the black hole remains an exaggerated pit. Strange, yes. Violent, yes. But still part of the ordinary imagination. The real black hole is colder. It is not saying, I pull harder than anything else. It is saying, your idea of where motion happens was incomplete. The clock falls because space-time tells matter how to move. Its light reddens because climbing out of gravity changes the energy carried to distant observers. Its final signals arrive stretched because time itself is not a universal agreement imposed from outside the universe. And the horizon waits, not as a surface, but as the boundary beyond which the old grammar of escape stops working. Gravity does not only move things. Gravity decides what paths can mean. Once that is understood, the black hole stops being a cosmic drain and becomes something more severe, a place where the familiar distinction between space, time, motion, and fate begins to dissolve. The darkness has not yet reached its deepest form. The first shadow is the realization that time was never safely separate from gravity. A clock can disagree with another clock. That sentence sounds minor until it is allowed to become physical. Not a metaphorical disagreement, not an error in construction, not one clock running poorly because its gears are damaged. Two ideal clocks, both working perfectly, can pass through the same universe and return with different amounts of time written into them. This is not philosophy wearing a lab coat. It is measured physics. Place one clock higher above Earth and one clock lower, closer to the planet's mass, and they do not tick at exactly the same rate. The difference is small because Earth is gentle compared with a black hole, small enough to hide from the body, small enough that ordinary life pretends it is not there. But precision does not forgive intuition. Atomic clocks can see what the nervous system cannot. Gravity changes time. Not time as a feeling, not time as memory, not the psychological stretch of a long afternoon or the collapse of a happy hour into minutes. Physical time, clock time, the kind carried by atoms, satellites, particles, and light. The first crack in the obvious is not that black holes are dark. The first crack is that time was never one thing everywhere. This matters because the mind has a private religion it rarely confesses. It believes in a universal now, somewhere beneath all our education, beneath relativity as a word we may have heard. We continue to imagine the universe as if it were unfolding under one enormous clock. Stars explode now. Galaxies collide now. A clock falls into a black hole now. We imagine different places as distant rooms inside the same present. But the universe is not arranged for our convenience. In relativity, time is not distributed like a single invisible mist filling all of space. Time is measured along paths. A clock does not merely sit inside time. It traces time through its motion and its gravitational environment. Its history is not only where it has been, but how much time it has accumulated while getting there. This is where the falling clock becomes dangerous. Far from the black hole, its ticking seems ordinary, a pulse every second, a clean rhythm. Information leaving the clock, traveling outward, reaching a distant observer. But as the clock descends into stronger gravity, each pulse must escape from a deeper region of curved space-time. The light loses energy climbing out. Its wavelength stretches, its color shifts toward red. And because the pulses themselves arrive farther apart, the clock appears to slow. The distant observer is not simply watching a bad image. The redshift and delay are part of the relationship between the clock's path and the observer's path. The light is carrying news from a region where time, relative to the observer far away, is being warped by gravity. The clock becomes a message written in longer and longer intervals. This is not because the clock feels itself dying. In its own frame, if it is small enough and freely falling, the local laws of physics remain normal at the horizon of a sufficiently large black hole. The hands move. The mechanism ticks. Nothing in that small room announces, "You have reached the place where distant observers will never receive your crossing as a completed scene." That is the cruelty of the event horizon. It is not necessarily locally dramatic. The universe can change the entire causal meaning of your future without placing a wall in front of you. To understand why this is so hard to accept, notice how much of ordinary thought depends on shared time. A meeting begins at 9. A signal is sent before it is received. A cause precedes an effect. A person leaves, then arrives. Even when things are far apart, we imagine there is some final account from which all events can be placed in order. Relativity does not destroy causality. It does something more subtle. It removes the naive background against which we thought causality was arranged. There are events that all observers agree can influence one another. There are events that cannot influence one another because no signal moving at or below light speed can connect them. And time ordering can depend on the observer when events are separated in the wrong way. Near a black hole, this is no longer an abstract lesson about trains and lightning bolts. It becomes architecture. The clock's ticking, its falling, its fading image, the distant observer's waiting, the infaller's finite journey. These are not contradictory stories pasted awkwardly onto one event. They are different slices through space-time. Each tells the truth allowed by its path. The body wants one master version. It wants to ask, did the clock cross the horizon or not? Did it freeze or fall through? Did time stop or continue? The answer is not a clean human answer, because the question smuggles in a clean human time. For the clock, the horizon can be crossed. For the distant observer, the received light from that crossing is never presented as an ordinary final frame. The clock appears to fade, redden, slow, and approach a boundary it never visibly passes. The disagreement is not a malfunction of description. It is the revelation that what happens is not fully separable from the space-time path along which it is described. This does not mean reality is subjective in the casual sense. The black hole is not whatever anyone feels it to be. The geometry is objective. The equations are severe. But the geometry does not supply the kind of universal viewpoint intuition demands. There is no cosmic balcony from which the entire scene can be watched with God's clock in the corner. That missing balcony is the real wound. The deeper the clock falls, the more our language starts to expose its origins. We say the clock is slowing down, but slowing relative to whom? We say it is near the horizon, but near according to which slicing of space-time? We say it is disappearing, but disappearing from whose future signals? The ordinary verbs still work, but only if handled carefully. Without care, they smuggle Newton back into Einstein. And black holes punish smuggled intuition. The redder light is not merely a visual effect, it is time made visible through wavelength. The increasing delay is not mere inconvenience, it is the stretching of causal access. The fading clock is not only a dim object, it is an object whose continuing story is becoming less and less deliverable to the outside universe. The darkness is beginning to acquire structure. Not yet the full structure of no escape, not yet the inward tilt of every possible future, but the first contour is visible. Time depends on gravity, and observers do not share one simple present. Once that enters the mind, the black hole can no longer be reduced to a dark mass pulling things inward. It becomes a machine for separating experience from observation, crossing from witnessing, event from image. A clock near a black hole does not simply tell time. It reveals that time has depth. And if time has depth, then falling is no longer just motion through space. It is motion through an uneven temporal landscape, where each step downward changes how the universe can receive the fact that you are still there. The old world had one time, and many places. The black hole gives us something harsher. Many paths, many clocks, one geometry. No privileged human now. The event horizon is not a surface. That is the next illusion that has to die. The human mind wants a boundary to behave like a boundary, a coastline, a wall, a door, a skin, something with a near side and a far side, something an object reaches at a definite moment, something that could be touched, crossed, photographed, approached with instruments. Even when the boundary is dangerous, we still want it to be local. We want the drama to happen there. But the horizon of a black hole is not made of anything. There is no metal shell around the darkness, no burning edge, no black glass, no membrane waiting in space with a sign on it saying, "This is where escape ends." If you fell through the event horizon of a sufficiently large black hole, and if you were small enough not to be torn apart by tidal gravity at that crossing, nothing in your immediate surroundings would necessarily announce the moment. Your pulse could continue, your watch could tick, a light beside you could still shine. Locally, physics would not need to scream. And yet something absolute has happened. That contrast is what makes the horizon so severe. It is not dramatic as a place. It is dramatic as a relation between events. It is a boundary in causality, not a substance in space. It marks the division between events whose future can still send light outward to the distant universe, and events whose future cannot. A surface can be recognized by touch. A horizon can only be understood by asking what can still communicate with what. This is why the word event matters. The horizon is not fundamentally a boundary around objects. It is a boundary around events. Something that happens outside can still, in principle, send signals to the wider universe. Something that happens inside cannot send any future-directed signal back out. The inside is not hidden because it is behind a curtain. It is hidden because no allowed path connects its future to the outside. The old picture says the black hole has an edge. The deeper picture says the universe has drawn a line through possibility. To see the difference, return to the falling clock. From far away, you never receive the clock's crossing as a clean final image. Its signals stretch and redden. Its rhythm thins. The horizon seems to hold the clock near its edge forever. But that is not because the horizon is a sticky surface, or because the clock is actually suspended there. The clock's own time carries it across. The distant observer's received light does not. A black hole separates the event from the report of the event. That separation is not a trick of poor eyesight. It is built into the structure. The horizon is where an entire class of reports becomes impossible. After crossing, the clock may still have a future, but its future is no longer a future that includes messages to the outside universe. It can still move, it can still tick, it can still encounter what comes next, but none of that can be translated into outward news. This is darker than invisibility. Invisible things can still affect us by signals we have not yet learned to detect. A hidden planet can tug on another orbit. Cold gas can absorb background light. Dark matter, whatever its final nature, announces itself gravitationally. In ordinary invisibility, the object may be hard to see, but the universe has not forbidden communication in principle. The inside of a black hole is different. It is not merely unseen, it is causally sealed. This is why the horizon cannot be understood as a normal border. A border usually separates places at one time. The event horizon separates possible futures. Outside it, a future-directed light ray can still climb away. At the horizon, the outward option becomes limiting. Inside, even light sent outward moves toward smaller radius in the only sense that matters, toward the black hole's interior fate. The phrase sounds impossible because it violates the picture in the head. How can outward light go inward? The problem is that outward is being borrowed from ordinary space, where directions are simple and time is not part of the trap. Near a black hole, space and time are braided tightly enough that ordinary direction words begin to break. Inside the horizon, moving deeper inward is not like choosing left instead of right. It is more like moving toward tomorrow. You do not avoid tomorrow by firing rockets. You do not stand still against it. You can change how you arrive, but not that you arrive. Inside a classical black hole, the singularity is not simply a place waiting at the center, in the way a stone sits at the center of a pit. It is, in the structure of the solution, something more like a future boundary for all inward paths. The details near that boundary are where classical general relativity is expected to fail, and quantum gravity is needed. But the causal lesson before that breakdown is already devastating. After the horizon, the inward direction has acquired the inevitability we normally associate with time. That is why the horizon is quiet. It does not need to burn you to matter. It does not need to flash. It does not need to exert a special local force at the crossing. Its horror is not sensory, it is structural. You cross a mathematical boundary, after which the external universe is no longer in your communicable future. This is difficult because the human imagination trusts surfaces. Surfaces help us think. The surface of Earth holds us up. The surface of water reflects light. The surface of a star burns. Even the surface of a planet we have never visited can be imagined as terrain. A surface lets the mind assign contact, pressure, texture, arrival. The event horizon denies this comfort. There is arrival without texture, crossing without collision, boundary without material, finality without impact. To call it dark is correct, but incomplete. The darkness of the horizon is not a pigment. It is not an object absorbing light like black velvet. It is a statement about which events can ever become visible from outside. The horizon's blackness is the blackness of an unanswered message that cannot be answered, not because no one speaks, but because every possible signal remains trapped in the wrong future. And this is where the black hole begins to invert ordinary thinking. In daily life, if something becomes invisible, we assume the limitation belongs to us. Our eyes are weak, our instruments are crude, the object is too small, too faint, too far, too obscured. We imagine better technology could fix the problem. Build a stronger telescope, wait longer, use another wavelength, detect a more subtle trace. But the event horizon is not a technological inconvenience. No better camera can photograph an event inside the horizon after it occurs and send that image back out. No patient civilization can wait long enough for a signal that has no allowed route. The issue is not that the message is delayed. The issue is that, once inside, the message does not belong to the outside's future. There is a kind of humility in this, but it is not comforting. It is the humility of discovering that reality has boundaries deeper than ignorance. Some things are not hidden because we have not yet learned enough. They are hidden because the structure of space-time denies the relationship required for knowing. The horizon is the place where knowledge becomes geometric. And once knowledge becomes geometric, darkness changes meaning again. It is no longer the absence of light in a region. It is the absence of access between histories. The falling clock may continue its private descent. The outside universe may continue its long expansion, its star formation, its cooling, its patient drift into future ages. But between those futures, the horizon has made a cut. Not a cut through matter. A cut through causality. So the black hole's edge is not where space ends. It is where certain conversations with the universe end, where an event can still happen, but can no longer report itself, where the clock can keep ticking, but its ticking has been removed from the shared ledger of the outside world. The horizon is not a surface you strike. It is the last address from which the universe can still receive your light. For most of human history, black holes were not objects waiting to be discovered. They were almost unthinkable. Not because people lacked imagination. The night sky has never suffered from a shortage of imagination. Ancient observers filled it with animals, gods, omens, calendars, empires of meaning. They watched stars appear and vanish with the seasons. They tracked planets wandering against the fixed background. They understood, long before modern physics, that the heavens were not random. There was order above the body, rhythm above hunger, a cold precision beyond human moods. But a black hole requires a more severe kind of imagination. It requires the willingness to believe that space and time are not the rigid container of events, but part of the events. It requires accepting that gravity is not simply a force between objects, but a reshaping of the geometry by which objects know how to move. It requires thinking of darkness not as a failure of illumination, but as a boundary in causality. That is not an easy idea to invent. The first steps toward it looked nothing like modern black holes. They looked like escape. If a cannonball is fired upward from Earth, it slows as gravity pulls it back. Fire it faster, and it climbs higher. Fire it fast enough, and it never returns. This is escape velocity, and in Newton's universe, it seems straightforward. Gravity is a force. Motion is through space. Time ticks behind everything with perfect impartiality. In that framework, one can imagine a body so massive and compact that its escape velocity exceeds the speed of light. Even in the 18th century, thinkers like Jean Michel and Pierre-Simon Laplace considered the possibility of dark stars whose light could not escape. The idea was astonishing, but it remained Newtonian in spirit. Light was treated almost like a projectile struggling against gravity. Darkness meant light tried to leave and fell back. That idea points in the right direction from far away. But it does not yet reach the black hole. Because a Newtonian dark star is still an object inside ordinary space, governed by ordinary time. It can be imagined as a star with enough gravity to trap light, a cosmic prison built by strength. The deeper black hole, the one forced on us by general relativity, is not merely stronger, it is stranger in kind. The turn came when Einstein changed the meaning of gravity. In 1905, special relativity had already damaged the old universe. It showed that measurements of space and time depend on motion, while the speed of light remains fixed for all observers. The damage was elegant, but incomplete. Acceleration and gravity still waited outside the door. Then came general relativity, completed in 1915, and the door did not open so much as disappear. Gravity became geometry. Mass and energy told spacetime how to curve. Curved spacetime told matter and light how to move. This was not a decorative reformulation. It changed the category of the problem. A falling object was no longer simply being pulled by a force in a flat arena. It was following a path through a dynamic geometry. The human model of reality had to bend before black holes could become real. And almost immediately, the theory produced something severe. Karl Schwarzschild, while serving on the German front during the First World War, found an exact solution to Einstein's field equations for the space-time outside a spherical mass. The historical fact is almost too stark. In the middle of human violence, a mathematical description appeared for a kind of gravitational silence deeper than any battlefield. His solution contained a radius, now called the Schwarzschild radius. Compress a non-rotating mass within that radius, and the geometry forms an event horizon. At first, the meaning of this radius was not clear. Mathematics often discovers shapes before human understanding catches up. Coordinates misbehaved. Singularities appeared in equations. Physicists debated whether these features were real, artifacts, impossible curiosities, or signs that nature would somehow avoid such collapse. The mind resisted. That resistance was not foolish. Science should resist easy astonishment. A mathematical solution is not automatically an astrophysical object. Nature may refuse what equations permit. Stars have pressure. Matter has structure. Collapse may halt. Unknown physics may intervene. For decades, black holes lived in a strange territory between implication and acceptance, as if reality had written a sentence no one was ready to pronounce. But the pressure kept building. Massive stars burn by balancing gravity against pressure from radiation and nuclear fusion. When their fuel runs out, that balance fails. Some become white dwarfs, some become neutron stars. But if enough mass remains, known forms of pressure cannot stop collapse. The star continues inward. Its surface shrinks toward the radius at which escape routes disappear from the external universe. The black hole emerges not as a monster added to physics, but as a consequence of physics refusing to blink. This is what makes the historical turn so important. Black holes are not the result of imaginative excess. They are the result of disciplined theory, carried into a regime where intuition begs to stop. General relativity did not set out to create cosmic abysses. It set out to understand gravity. The abyss came as part of the price. And the price was not only mathematical. Once black holes became physically plausible, the old ideas of time, observation, and objecthood began to fracture. A star collapsing toward a horizon does not simply become a smaller star. It changes its relationship to the rest of the universe. From the outside, its surface appears to slow, redden, and fade. The collapsing matter does not present a final, visible crossing. Its image is stretched toward silence. But according to the collapsing matter's own time, the journey continues. History had not merely discovered a new type of body. It had discovered a new type of disappearance. This is why black holes could not be properly understood by adding more gravity to Newton. Newton could imagine dark stars, but not horizons as causal boundaries. Newton could imagine light failing to escape, but not space-time tilting possible futures inward. Newton could imagine forces growing extreme, but not the failure of a shared universal time. The revolution was not that the universe contained darker objects than expected. The revolution was that the universe contained regions where the word object became unstable. A normal object can be described from the outside in terms of its surface, its light, its position, its motion. Even if the object is hidden, those categories remain intact. A black hole is defined from the outside by what cannot return. Its most important feature is not a material surface, but a boundary in the causal structure. It is identified by absence, but not an empty absence, a lawful absence, a precise absence, an absence with mass, spin, temperature, entropy, gravitational influence. This is the severe beauty of the subject. The black hole is not vague mystery. It is not a poetic darkness inserted where science fails. It is what happens when successful science becomes too exact for human pictures. Even the name arrived late. Black hole sounds ancient, but it is modern. Before the term settled into public language, physicists spoke of gravitationally completely collapsed objects, frozen stars, singular solutions. The final name was simple enough to become mythic, but simplicity can mislead. It makes the black hole sound like a pit. It hides the historical violence done to ordinary thought before the phrase could make sense. A black hole is a triumph of naming and a failure of naming at the same time. Black is too visual. Hole is too spatial. What the theory revealed was darker than both words. A region where gravity has become geometry, so extreme that time and escape are no longer separable. The falling clock belongs to that history. It is not just a prop in a thought experiment. It is the heir of centuries of corrected intuition. The clock falls through Newton's language, through Einstein's geometry, through Schwarzschild's radius, through the collapse of the idea that the universe must keep one time for all witnesses. Each tick carries the old world toward its breaking point. And once the model has bent this far, another structure begins to appear beneath the surface of the story. Not a surface, not a force, not a pit. A pattern of possible futures. To see that pattern, the mind needs a new image, not of objects falling, but of light itself trying to decide where tomorrow is allowed to go. A light cone is a quiet diagram of fate. Draw one event as a point, not an object, not a place exactly, but an event, a flash, a tick, a collision, one precise happening in space-time. From that point, imagine all the paths light could take afterward. Since nothing can outrun light, those paths form the outer limit of what the event can influence. Everything slower than light must travel inside that limit. Everything outside it cannot be reached, not yet, not by any signal permitted by physics. The shape is called a cone because, in a simplified drawing, time rises upward and space spreads outward. Light traces the slanted sides. Massive objects move inside. The future is not everywhere. It is the region inside the cone. At first, the image seems abstract, almost too clean to carry terror. A cone on a board. Lines, angles, axes. But the diagram is not decoration. It is a map of permission. It tells you where cause can go. It tells you what can still be touched by a signal, warmed by a photon, altered by a decision, warned before arrival. A light cone is the architecture of possible communication. In flat space-time, far from extreme gravity, those cones stand upright. They lean neither toward disaster nor escape. An event can send light in every spatial direction. A lamp can shine left, right, upward, downward. A clock can broadcast its ticks outward into the surrounding universe. There are limits, but the limits feel fair. You cannot exceed light speed, but within that rule, the future opens around you. Near a black hole, the cones begin to tilt. Not because light becomes tired, not because space turns into a substance pushing it inward. The tilt is a way of seeing curved space-time. The geometry changes what counts as future-directed motion. As the clock falls closer to the horizon, the possible paths for its light no longer spread through space-time in the old symmetrical way. More and more of the cone leans toward the black hole. Escape routes narrow. Outward signals can still exist, but they must follow increasingly strained paths through geometry. At the event horizon, something exact happens. The outward side of the light cone lies along the horizon itself. Light aimed outward does not climb away to distant stars. It hovers, in the geometric sense, on the boundary. The horizon is generated by light rays that never escape to infinity and never fall inward in the ordinary outside description. They mark the edge of return. Then, inside, the cone tips past the point of rescue. Every future-directed path points deeper in. This is the hidden machinery behind the phrase, "nothing can escape." Without light cones, that phrase sounds like a contest. Light tries to leave. Gravity pulls harder. Light loses. But with light cones, the contest disappears. Escape is not a failed attempt. Escape is no longer included among future possibilities. The difference is brutal. A rocket inside the horizon can fire its engines outward. A lamp can shine outward. A person can point, struggle, choose, calculate, burn fuel, scream into a transmitter. None of that changes the cone. The future available to those actions remains inward. The rocket may affect how quickly it reaches what lies deeper. It may alter its path within the cone, but it cannot rotate the cone back toward the outside universe. This is why the horizon is more like time than like a wall. You can move in many ways through tomorrow. You can sleep or run, turn left or right, speak or remain silent. But you cannot move back into yesterday by effort. The direction is not imposed by a surface blocking you. It is woven into the ordering of events. Inside a black hole, inward becomes that kind of direction. Not identical to ordinary time. The metaphor must be handled carefully, but close enough to wound intuition. The singularity, in classical general relativity, is not simply sitting ahead as a central object in space. It lies in the future of anything that has crossed the horizon. You do not approach it the way a traveler approaches a city. You approach it the way every living body approaches its next moment. Except the next moment is not gentle, and the classical equations suggest that curvature grows without bound. That final prediction is not a completed physical description. It is a warning sign inside the theory, a place where the theory points to its own incompleteness. But the causal trap does not wait for that final unknown to become meaningful. The trap has already closed at the horizon. The falling clock now carries a new significance. Its ticks are not merely delayed by gravity. Its possible futures are being narrowed by geometry. Before the horizon, some signals can still escape. After the horizon, no signal sent from the clock belongs to the outside's future. The clock may continue to emit light locally. Its face may still shine in its own small neighborhood, but the light it sends outward is outward only by old intuition. In the deeper structure, it remains inside the inward-leaning future. This makes black hole darkness almost unbearable to picture correctly. It is not a curtain drawn over an object. It is not black paint covering a surface. It is not even merely extreme dimness. It is the failure of outgoing paths to remain outgoing in the global causal sense. The technical language can be dry, but the meaning is severe. The universe has closed the set of routes by which that event can become visible outside. The event happens. The report cannot leave. Think of the clock's last possible outward messages before the crossing. Each one escapes from closer to the edge. Each one is stretched, delayed, reddened. They arrive carrying an older and older version of the clock, never the final local experience of crossing. Then the clock passes into a region where all its later flashes, however bright nearby, have futures that remain inside. To the outside universe, the clock's accessible story has been compressed into a fading archive near the horizon. Inside, there may be more story. Outside, there is no more news. That distinction is the beginning of real darkness. A black hole is often introduced as something from which not even light can escape. But light cones reveal a more exact and more disturbing statement. The black hole is a region where every future light cone has been turned away from the outside world. Darkness is not produced by swallowing photons one by one. It is produced by the geometry that decides where photons can ever go. And because light is the carrier of sight, heat, signal, evidence, and causal contact, the tipping of light cones is also the tipping of knowability. What cannot send light, or anything slower than light, cannot announce its later events to us. The outside universe may infer the black hole's mass, spin, charge, and principle, its influence on nearby matter, its role in a merger, its ring down through gravitational waves. But the interior events themselves are not part of the outside's communicable future. The machinery is silent because it is exact. No hand grabs the light, no cosmic mouth closes, no visible edge clamps shut. The cones tilt, the horizon forms, and possibility changes its shape. The black hole gets darker once time is included, because time is where the trap is built. Not in the material of a surface, not in the strength of a pull, and the allowed directions of the future. The first 6 steps of the descent have quietly removed the word dark from the eye. At the beginning, darkness seemed like a visual condition, a place without light, a surface that absorbs every color, a cosmic object so black that even the imagination paints it as absence. But once time enters the picture, that simple darkness begins to fracture. The black hole is not merely difficult to see, it is difficult to remain connected to. That distinction changes everything. To see something, light must leave it and reach you. But seeing is only one member of a larger family. To measure something, some signal must connect the event to an instrument. To be warned by something, information must arrive before consequence. To remember something in the external universe, traces must survive in a place where they can still be read. Sight, evidence, warning, memory. All of them depend on causal contact. A black hole is where that contact is cut. The object outside the horizon may still belong to the shared world. Its light may be stretched and delayed, but it can still speak outward. Its influence can still be reported. The universe can still receive news from it, even if the news arrives wounded by gravity. But once an event lies inside the horizon, its future signals no longer intersect the distant outside. It has not simply become dim, it has been removed from exchange. This is the deeper darkness. Not blackness as color. Blackness as lost relation. The falling clock helps because it gives the loss a rhythm. Each tick before the horizon is a small act of survival. A pulse leaves the clock, climbs outward, and enters the wider universe. It may arrive weakened, it may arrive after a long delay. Its color may have been dragged toward red by the climb, but it arrives. It says, in the only language light can speak, this happened. The clock was there. The clock still belonged to your future. Then comes the boundary after which no later tick can make that statement to the outside. The clock may still tick. The tragedy is not that its mechanism ceases at the horizon. The tragedy is subtler. The ticking has become private in a new physical sense. Not private because no one happens to listen. Not private because the signal is encrypted. Private because the geometry of space-time no longer permits the outside universe to be among its recipients. The horizon turns later events into facts without witnesses outside. This sounds almost psychological, but it is not. It is not loneliness projected onto physics. It is the structure of allowed influence. We are used to thinking that if something exists, then in principle enough patience, enough technology, enough cleverness might reveal it. Black holes deny that optimism. They do not say our instruments are weak. They say the relevant paths are absent. There is no future in which the inside sends a postcard out. That line should not be made mystical. It is simply what the causal boundary means. But its emotional pressure is real because human knowledge is built on the belief that the hidden can become known. Science thrives by turning invisibility into evidence, atoms through tracks and spectra, planets through orbital wobbles, viruses through microscopes, gravitational waves through the faint stretching of interferometer arms. Again and again, reality has yielded to indirect contact. The black hole interior is not like that. We can know the horizon from outside. We can measure the black hole's mass through orbits. We can infer spin. We can observe hot gas near the edge, gravitational lensing, relativistic jets, mergers, ringdowns. We can test general relativity in the strong field regime. The outside of the black hole is scientifically rich, not a blank. But the events beyond the horizon do not become accessible by building a sharper eye. Their inaccessibility is not practical. It is causal. That is why black holes feel like a limit drawn inside knowledge itself. They force a distinction between existence and availability. Something may happen. Something may have a perfectly real local history. It may be described by a falling observer for as long as that observer survives. And still, that history may not be part of the outside world's reachable archive. The universe is not required to make every fact publicly reportable. This is not how the mind wants reality to behave. The mind likes a shared ledger. It wants all true events written somewhere in a book that could, at least in principle, be opened. But the horizon cuts the ledger. It does not erase the mass energy. It does not remove the black hole's gravitational presence. It does not make physics vanish. It removes a channel. It says, from here onward, this story no longer sends messages back. The darkness becomes administrative in the coldest possible sense. A boundary in what can be filed into the outside universe's future. The word dark now carries less color and more finality. A dark room can be searched. A dark ocean can be crossed. A dark planet can be mapped by radar. A dark age can leave fossils, ruins, chemical traces, relic light. Ordinary darkness is generous compared with this. It hides things temporarily, imperfectly, circumstantially. A black hole's horizon hides later interior events by the structure of causality. That is why the phrase, "nothing can escape," is less profound than it first sounds. It still tempts the mind into imagining things trying to escape and failing. The deeper statement is that the future inside does not include outside arrival. There is no heroic photon fighting upward and losing in slow motion. There is simply no allowed future-directed path from the interior event to the distant observer. The photon is not defeated. It is never offered the outside as a destination. This is what the clock has been teaching from the beginning. The reddening pulses were not merely a special effect on the edge of a cosmic pit. They were the last public sentences of a private descent. Each one carried a little less energy, a little more delay, a little older version of the falling object. They were not the crossing itself. They were the universe's final reachable reports before the report line ended. And because all observation depends on reports, the black hole becomes more than an object. It becomes a lesson in the politics of reality. Who can still speak to whom? Which events remain in the common world? Which futures are shared? And which futures are sealed away behind geometry? There is no malice in this. That makes it worse. The black hole does not choose silence. It does not devour information with appetite. It does not hate light. It is not dramatic enough for mythology. It is a lawful arrangement of space-time in which outward communication from the interior is not among the possibilities. Its darkness is calm because the equations are calm. It is final without rage. This is where the viewer's old intuition should begin to feel very small. We entered with the idea of a dark thing in space. We have arrived at a darker idea, a boundary beyond which events can continue while ceasing to belong to our causal world. A place where the universe does not merely hide what happens, but prevents happening from becoming news. The black hole is dark because light cannot return. It is darker because time cannot bring the inside back into conversation. The real question was never why light cannot escape. That question is useful at the beginning because it gives the mind a handle. Light is the fastest thing there is. If even light cannot get out, the place must be extreme. The statement has force. It carries the right kind of astonishment, but it also keeps the imagination trapped inside a simple contest. Light going outward, gravity pulling inward, one side overpowering the other. A black hole is not fully understood until that contest disappears. The deeper question is not whether light is strong enough. Light has no strength in that sense. It follows the path space-time gives it. The deeper question is what happens when space-time changes the meaning of future so completely that outward arrival no longer exists as an option. That is the renewal point. The subject has grown larger than the object. We are no longer asking about a strange astronomical body. We are asking about the architecture of possibility. This is where black holes become more disturbing than their popular image. The familiar image is violent, matter spiraling, stars torn open, gas heated to intolerable temperatures, magnetic fields launching jets across interstellar distances. These scenes are real around many black holes, and they are physically important, but they are not the deepest thing. Violence is still easy to understand. Heat, pressure, collision, destruction. The body knows these. It may fear them, but it can imagine them. Causality is harder to fear because it has no face. You do not see causality directly. You infer it from sequence, signal, influence. A match strikes and flame appears. A hand moves and a cup falls. A star collapses and gravitational waves ripple outward. Our minds grow inside this web until it feels like reality itself is made of common sense connection. Things happen and other things can find out. The event horizon breaks that habit. It does not break causality in the sense of chaos or contradiction. It does not make events happen without order. It does not turn physics into dream logic. It does something more precise and more severe. It partitions causality. It creates a region whose future remains internally ordered, but externally mute. Inside, events can still follow events. Locally, causes can still have effects. A falling observer can still receive light from objects falling nearby. Instruments can still record. A heartbeat can still precede a thought. But none of that continuing order opens a path back to the outside universe. The interior does not become unreal. It becomes unavailable. That difference is the hinge of the entire story. If the interior became unreal, the mind could dismiss it. If physics simply ended at the horizon, the problem would be crude. But the horizon is not the end of local reality. It is the end of outward report. The inside may contain experience, structure, sequence, and finite proper time, while remaining permanently removed from the external record by classical causality. A thing can remain real and stop being reachable. That sentence is colder than the phrase, "nothing escapes," because it does not speak only about black holes. It speaks about the limits of any being whose knowledge depends on signals. We never know reality directly. We know what reaches us: photons, particles, vibrations, fields, correlations, traces. The universe touches itself through permitted interactions, and observers are arrangements that receive some of those touches. The black hole is a place where the permissions are redrawn. It forces humility without asking for it. Not the soft humility of standing beneath stars and feeling small, something stricter, a technical humility. The recognition that, in principle observable, is not the same as real, and not observable from here is not the same as imaginary. The event horizon places a disciplined silence inside the map of the universe. At this midpoint, the old title changes meaning. Black holes get darker once you include time, because time reveals that darkness is not merely about what light does now. It is about which futures can ever connect. A photon emitted outside the horizon may arrive late, weakened, reddened, but it can still become part of distant history. A photon emitted inside, aimed with all the urgency a photon can have, remains inside the causal future of the black hole. Its speed is perfect. Its fate is sealed. The speed of light is not a magic key. It is the boundary of the prison. This is why the horizon feels almost paradoxical. The same universal limit that allows causal order also defines the edge of no return. Light speed keeps the universe from becoming a chaos of instant influence. It preserves sequence. It gives causality its shape. But near a black hole, that same rule helps form the trap. If nothing can outrun light, and light cones tip inward, then no slower thing has a hidden escape route. The law that protects order becomes the law that seals silence. There is no need to add supernatural darkness. The known rules are sufficient. That is what makes the black hole so elegant and so unsettling. It does not require physics to fail at the horizon. It requires physics to work with exactness. The event horizon is not where the universe becomes lawless. It is where the law becomes inescapable. For the falling clock, this means its journey has shifted from spectacle to ontology. We began by watching a signal fade. We thought perhaps we were seeing an extreme optical effect. Then we learned that the fading was tied to gravitational time dilation, redshift, observer dependence, and the geometry of possible futures. The clock is no longer merely an object becoming hard to see. It is a test of what it means for an event to remain in relation with the rest of the universe. Before the horizon, every tick says, "I can still be part of your future." After the horizon, the ticks may continue, but that sentence can no longer be sent. This is the second ignition of the descent. The black hole is not only a place that traps light, it is a place that separates happening from being reportable, experience from external history, local future from shared future. It makes visible the fact that reality is not built around observation. Observation is a privilege granted only where causal paths allow it. The universe is not obligated to keep every event available to every future. Once this is understood, the emotional texture of black holes changes. The horror is not that they are hungry. Hunger is biological. It belongs to animals, myths, gods made in our image. A black hole has no hunger. It has geometry. It does not want the clock. It does not chase the light. It does not darken itself with intention. It simply contains a boundary after which outward future is absent. That absence is enough. Now the descent can widen. Because real black holes are not found as perfect diagrams, floating alone in mathematical emptiness. They live in galaxies. They bend starlight. They tear gas into disks. They convert gravitational energy into radiation. They can sit at galactic centers, surrounded by brilliance. The strangest thing about them is not that everything near them is dark. The strangest thing is that the universe can build its brightest fires around a place that cannot answer. The horizon remains quiet while the cosmos burns around it. The horizon is silent, but the region around it can be violently bright. This is the contradiction that saves black holes from becoming simplistic symbols. If they were only dark spheres floating in empty space, the imagination would settle too quickly. It would make them into cosmic absences, holes cut from the fabric of the sky. But real black holes often announce themselves through excess, not absence. They are found by what happens near them, by stars whipped into impossible orbits, by gas heated until it glows in X-rays, by jets launched across distances the human mind cannot carry without losing scale. The darkness is not lonely. It is surrounded by evidence. A black hole with matter nearby becomes a machine for turning gravitational depth into radiation. Gas does not fall straight in like rain through a drain. It usually carries angular momentum, a tendency to orbit rather than plunge. So it gathers into a disk, circling, shearing, colliding with itself. Inner rings move faster than outer rings. Friction and turbulence convert orbital energy into heat. Magnetic fields twist through plasma. Matter becomes luminous because it is not yet lost. The brightest light may come from material approaching the place from which no light returns. This is not a contradiction, it is the key. The accretion disk is outside the event horizon. Its photons still have possible futures that include distant telescopes. Its violence remains communicable. Gas can scream in radiation before crossing the causal boundary. The horizon itself does not need to shine. It only waits at the center of the process, not as a surface waiting to be struck, but as the line after which the story cannot report back. In some systems, black holes power quasars, among the most luminous, persistent objects in the universe. A supermassive black hole at the center of a galaxy can feed on surrounding matter so efficiently that the region near it outshines the stars around it. The popular mind hears black hole and thinks pure darkness. The sky answers with blazing disks. But the blaze is not the whole. The blaze is the last public violence before silence. This distinction matters because it prevents the script from turning black holes into emptiness. A black hole is not a blank in the universe. It has mass. It shapes orbits. It bends light. It can merge with another black hole and shake spacetime itself. It can anchor galaxies, disturb stars, lens background objects, and leave fingerprints across cosmic structure. It can be one of the most influential things in a region while remaining unable to show its interior. Influence and visibility separate. That is another rupture. In daily life, powerful things tend to be evident. Fire gives heat, a storm gives wind, a mountain occupies the horizon, a body has a surface. Presence and appearance remain close enough that the mind fuses them. But black holes teach a harsher lesson. Something can dominate its surroundings while offering no surface to see. Its reality is not in direct display, but in the shape it imposes on everything allowed to remain outside. Even the famous images of black holes are images of this surrounding structure, not snapshots of the interior. The dark central region in such images is not a photographed surface. It is the shadow produced by light bending, by photon paths, by the absence of escaping light from the horizon region, by glowing matter arranged around a causal boundary. We do not see the black hole the way we see the moon. We see the universe failing to send us light from certain directions. A black hole appears by editing the background. This is why the expanded field matters. The subject has moved from a falling clock to a cosmic environment. The same principle is still operating, but now it has grown larger. The horizon cuts off outward futures. Around that cut, matter remains visible until the last allowed moment. The universe lights up the edge of what cannot speak. There is something almost severe in the contrast, the most silent boundary in physics, surrounded by some of the loudest environments in astronomy. The silence is not weakness, it is not emptiness, it is the disciplined refusal of causal return. The disk can glow, the jets can extend, the surrounding stars can betray the mass hidden at the center, but the horizon does not answer. It is possible to mistake this for mystery in the cheap sense, a hidden center, a cosmic secret, a forbidden interior. But the real power comes from the opposite. We know why the horizon does not answer. At least classically, the reason is not romantic, it is geometric. Future-directed causal paths from inside do not reach the outside. The darkness is explained, and the explanation makes it stranger. Knowledge does not dissolve the shadow. Knowledge sharpens its edge. The accretion disk also reveals why time cannot be removed from the picture. Matter orbiting close to a black hole moves at relativistic speeds. Light from different parts of the disk reaches us distorted by motion, gravity, and path length. Some regions appear brighter because their material is moving toward us. Some light bends around the black hole before arriving. Some photons circle near unstable paths before escaping. The image is not a simple photograph of a thing. It is a time-delayed, gravity-shaped arrangement of signals. When we look near a black hole, we are not seeing a single clean moment. We are receiving a negotiation between geometry, motion, and time. Every photon that reaches us has survived a path through curved space-time. It has escaped the wrong side of the boundary. It has not merely traveled far, it has passed through a region where the distinction between direction and destiny becomes fragile. Even the light we do receive is a survivor of geometry. That makes the darkness at the center heavier. The surrounding brightness is not a denial of the title. It is the reason the title deepens. Black holes get darker once time is included, because the light around them becomes legible as the last evidence of what remains outside causal silence. The brighter the disk, the more absolute the horizon appears by contrast. The universe can blaze at the edge and still fail to illuminate what lies beyond it. A candle near a cave can reveal the cave wall. A quasar near a horizon reveals that there is no wall. Only a boundary and future-directed possibility. This expanded view also removes another illusion, that darkness means inactivity. Black holes can grow, they can spin, they can merge. Their surrounding disks can flicker and flare. Their gravitational fields can sculpt entire regions. Supermassive black holes can regulate galaxy evolution through feedback, injecting energy into surrounding gas and influencing whether stars form. None of that requires the horizon to reveal its interior. The black hole participates in cosmic history from the outside, through gravity and through the behavior of matter not yet crossed. It is causally silent inward, not gravitationally absent outward. That sentence matters because it keeps the idea precise. The horizon blocks signals from interior events escaping. It does not erase the black hole's external gravitational field. The outside universe still responds to mass, spin, and surrounding dynamics. A black hole can be inferred, modeled, measured, and tested. It is not unknowable in every sense. It is knowable at the boundary of what can communicate. The expanded field is therefore not emptier than expected. It is more layered. Brightness outside, silence inside, influence without surface, visibility without access, fire wrapped around a future that does not return. Return once more to the clock, now no longer alone. Imagine it falling through a disk of incandescent gas, past particles orbiting at enormous speed, through light bent into arcs, through radiation that may travel outward and become data in a telescope. For a while, the clock belongs to the blaze. Its signals mingle with the rest of the visible violence. Then, the boundary takes over. Later ticks remain local. Later light remains inward. The clock crosses from the brilliant, reportable universe into a future that cannot publish itself. Around the black hole, the cosmos may burn. At the horizon, tomorrow goes quiet. Human intuition is a local instrument. It was not shaped beside horizons. It was not shaped by neutron stars, relativistic jets, colliding black holes, or the last stable orbits of plasma moving near light speed. It was shaped by fruit falling from branches, stones in the hand, weather on the skin, daylight crossing a field, footsteps judged by balance and threat. The body learned a universe where gravity is weak, speeds are slow, and time seems to belong to everyone at once. That universe is real. It is also provincial. Every instinct we bring to a black hole arrives from a narrow province of reality. The province is generous enough for life, memory, language, and science to begin, but it is not wide enough to make common sense universal. Near a black hole, common sense is not merely incomplete, it becomes an unreliable narrator. The first failure is spatial. We imagine space as a container. Things move through it. Places are laid out side by side. Directions feel stable. Outward means away from the center. Inward means toward it. A horizon, if it exists, should be an edge in that container. But near a black hole, the container picture has already lost too much. Space and time are not separate stage and clock. They form space-time, and space-time has geometry. Direction cannot be understood without time, because motion is not just where something goes, but which future it follows. Inside the horizon, the word outward keeps its emotional meaning while losing its physical escape value. The mind keeps pointing away. The light cone keeps pointing in. The second failure is temporal. We imagine time as a universal river carrying all events forward together. Clocks may be inaccurate, people may disagree, signals may arrive late, but somewhere beneath the confusion, there should be one correct cosmic schedule, one true now, one final bookkeeping of what has happened everywhere. Relativity removes that hidden comfort. Clocks measure time along paths. Motion matters. Gravity matters. The amount of time accumulated by one clock is not guaranteed to match the amount accumulated by another. This is not a philosophical inconvenience. It is built into satellite navigation, particle lifetimes, gravitational redshift, and the behavior of light near massive objects. The universe does not provide a master clock behind the scenes just because the human mind wants one. Near a black hole, this becomes impossible to ignore. The falling clock crosses the horizon in its own finite proper time. The distant observer does not receive the crossing as a clean final frame. The clock's light stretches, reddens, thins, and fades. The body wants to ask which version is real, but the demand for one simple version is the residue of the old province. Both descriptions are disciplined by the same geometry. The contradiction belongs less to physics than to our expectation that all truths must fit inside one shared human picture. The third failure is visual. We believe seeing is close to knowing. We know this is not always true, yet perception remains our native authority. A thing seen feels more real than a thing inferred. A surface gives comfort. A photograph gives ownership. A horizon, then, should be something we could eventually see better. But the event horizon is not a surface waiting for a sharper camera. It is a causal boundary. No instrument can receive a signal from a later interior event and bring it outside, because no such outward causal path exists. Better technology can reveal more about the environment, the shadow, the disk, the gravitational field, the waves from mergers, the behavior of matter before crossing. It cannot turn a forbidden future into an allowed one. The limit is not optical. It is structural. This is where intuition experiences its quiet humiliation. We are used to ignorance being temporary. The history of science is full of hidden things becoming visible by indirect means. Bacteria, galaxies, exoplanets, neutrinos, gravitational waves. Again and again, reality has yielded to improved methods. So the mind expects the horizon to become another frontier, another darkness awaiting a better lamp. But some darkness is not waiting for light. Some darkness is made of the absence of a route. The fourth failure is emotional. We want reality to become more comfortable as it becomes more understood. This expectation is rarely stated, but it guides much of popular imagination. Explanation should dissolve fear. Mechanism should tame mystery. Knowledge should turn the strange into the familiar. Black holes refuse this bargain. The more accurately they are understood, the less they resemble the simple monster. But they do not become safer to the mind. They become colder. A monster can be theatrical. A cosmic drain can be visualized. A destructive object can be feared in familiar terms. A causal boundary is harder to metabolize. It does not threaten like an animal. It does not rage. It does not choose. It simply reveals that the deep universe is lawful in ways our emotions cannot easily inhabit. The black hole is not terrifying because it violates order. It is terrifying because it is order. That sentence marks the limit of intuition more sharply than any image. Human instinct expects terror to come from breakdown, explosion, chaos, rupture, madness, the failure of rules. But the event horizon is not a failure of rules. It is a consequence of them. General relativity does not become vague at the horizon. The geometry remains clean. Local physics can remain ordinary for a falling observer crossing a large black hole's horizon. The horror is not that the law stops. The horror is that the law continues without caring whether its implications are psychologically livable. The body wants special effects. The universe gives coordinates, curvature, and causal structure. This mismatch is why black holes are so often simplified into images that restore human scale. Whirlpool, mouth, pit, abyss, monster. These metaphors are not useless, but each smuggles in something comforting. A whirlpool is in water. A mouth belongs to a creature. A pit has walls. An abyss is still imagined as a place. The real horizon is worse because it is less pictorial. It is not primarily a thing to look at. It is a change in what future-directed paths can do. The mind keeps asking for an object. The physics gives a relation. Even the phrase falling in is a concession. It helps the story move, but it carries ordinary downwardness into a place where downward has become an inadequate word. The clock does not fall in the same sense a stone falls to earth. It follows a world line through curved space-time. It moves from a region where signals can reach infinity to a region where later signals cannot. Its journey is not only a change of position, it is a change in causal membership. It leaves the shared future. That is the limit intuition cannot cross cleanly. We can calculate past it. We can model the exterior. We can describe the horizon. We can distinguish proper time from coordinate time. We can use diagrams, equations, simulations, and observations. But the old inner picture does not survive intact. It has to be replaced by something colder and less human. Events, world lines, light cones, causal boundaries, geometry. The reward for that replacement is not comfort. It is accuracy. And accuracy, near a black hole, has a strange moral texture. It asks the mind to stop demanding that reality be imageable before it is believed. It asks us to accept that the universe may be perfectly intelligible in mathematics, while remaining hostile to ordinary imagination. It asks us to admit that our deepest intuitions were not wrong because they were foolish, but because they were local. The falling clock has been descending through that admission all along. Every redshifted pulse stripped away another assumption. Space was not a container. Time was not universal. Darkness was not visual. The horizon was not a surface. Escape was not a contest. Observation was not guaranteed. What remains is more exact and less merciful. A black hole is where common sense reaches the edge of the environment that made it. Beyond that edge, reality does not become unreal. It becomes non-human. Understanding does not remove the black hole. It removes the wrong mystery and leaves a harder one behind. At first, the mystery seemed visual. Why is it dark? Then it became gravitational. How can gravity trap light? Then temporal. Why do distant clocks and falling clocks disagree? Then causal. What does it mean for a region of space-time to lose outward futures? Each answer sharpened the shape of the problem. Each answer made the black hole less like a myth and more like a machine. But the machine does not become simple. That is the price of understanding. The first layer of darkness can be explained with great confidence. General relativity tells us how mass and energy curve space-time. It tells us why light follows null paths. It tells us why horizons form when collapse passes a certain threshold. It tells us why signals from near the horizon are redshifted and delayed. It tells us why the event horizon is not a material surface, and why crossing it need not be locally dramatic for a sufficiently large black hole. This is an extraordinary victory. It is also not the end. Because once the horizon is understood, the mind naturally asks what lies beyond it, not in the childish sense of wanting a photograph from inside, but in the deeper physical sense. What does the theory say happens to the matter, the light, the clock, the star, the information, the history that crosses the boundary? Classical general relativity gives a severe answer. For an ideal non-rotating black hole, everything inside moves toward a singularity, a region where the curvature described by the theory grows without bound. In the mathematics, distances shrink toward an end. Densities and tidal forces become extreme. The paths that entered the horizon do not wander forever through some spacious interior. They reach the place where the classical description ceases to remain physically trustworthy. The word singularity is dangerous because it sounds like a thing. It is better understood as a warning. A singularity is not a fully understood object sitting at the center, waiting like a hard bead of infinite density. It is a sign that the theory has been driven beyond the range where it can give a complete answer. General relativity has carried us with astonishing precision, from falling apples to gravitational waves, from Mercury's orbit to black hole mergers. But at the singularity, its own language becomes too extreme. Quantities that should remain physically meaningful begin to misbehave. The map does not merely show difficult terrain, the map tears. This does not make the theory weak. It makes the boundary of the theory visible. Physics has seen this before. A successful theory can reveal the conditions under which it must be replaced or completed. Newtonian gravity did not become useless when Einstein arrived. It became an approximation within a larger framework. Classical thermodynamics did not vanish when statistical mechanics deepened it. It found its microscopic machinery. In the same way, the singularity may be less a destination than a demand. Here, gravity must somehow speak quantum language. But no complete, experimentally confirmed theory of quantum gravity has yet taken the place of classical general relativity at that depth. That absence is not decorative uncertainty. It is one of the deepest open wounds in physics. The black hole, therefore, becomes a double structure. At the horizon, relativity can be clean and powerful. Near the singularity, that same theory points toward its own incompleteness. The object that began as the triumph of geometry becomes a doorway into the place where geometry alone may not be enough. The clock falls through both facts. At the horizon, it does not encounter a known physical surface. It crosses a causal boundary. Its later signals cannot return to the outside. But deeper in, as it moves toward regions of stronger curvature, the local conditions become increasingly violent. Tidal forces grow. The difference in gravity between one side of the clock and the other can stretch and compress it. For a small black hole, these forces near the horizon could be destructive. For a supermassive black hole, the horizon crossing could be gentle, but the deeper future remains severe. The clock may cross quietly. It does not end quietly forever. This distinction matters because popular black hole images often place all the drama at the horizon. The edge becomes the theatrical moment. The crossing becomes the imagined point of doom. But physics is subtler. The horizon is not where local catastrophe must occur. It is where return becomes impossible. The singularity, or whatever replaces it in a more complete theory, is where the interior future demands an answer we do not yet possess. So knowledge has split the darkness. One darkness we understand, the darkness of causal disconnection. One darkness remains open, the darkness of ultimate interior fate. And between them lies the intellectual pressure that makes black holes more than astronomical objects. They are places where our two most successful descriptions of nature face each other without yet merging cleanly. General relativity describes gravity as geometry on large scales and strong fields. Quantum theory describes matter, energy, and information at small scales with unmatched precision. Black holes force both languages into the same room. They do not allow the universe to remain divided into departments. The collapsing star is massive, gravitational, cosmic, but its end may involve quantum questions about information, entropy, and microscopic degrees of freedom. The horizon is enormous in some black holes, wider than planetary orbits, yet its deepest meaning may depend on principles discovered in the smallest domains of physics. Scale, once again, betrays intuition. The largest darkness in the sky may require the smallest rules in nature. That is the pressure of understanding. The naive mind wants a black hole to be one mystery. Science reveals that it is a convergence point for many mysteries that cannot be honestly separated. Gravity, time, thermodynamics, quantum theory, information, causality, observation. The more precisely one mechanism is explained, the more forcefully another question appears behind it. This is not failure. It is what real depth feels like. A weak mystery dissolves when explained. A strong one changes form. It becomes less vague and more demanding. Black holes have survived explanation because each layer of understanding has made them less available to ordinary imagination, not more. The horizon is not spooky because we lack equations. It is spooky because the equations are clear. The singularity is not serious because it is poetic. It is serious because the equations stop being enough. The old darkness was ignorance. The new darkness is a border between known law and unfinished law. That border should not be exaggerated into fantasy. We should not fill the interior with tunnels, other universes, cosmic shortcuts, or convenient speculation, merely because the equations become incomplete. Some mathematical extensions and theoretical ideas exist, and some are worth studying, but the responsible emotional force comes from what is actually known. Classical collapse produces horizons. Horizons create causal separation. Singularities indicate the breakdown of the classical theory. A deeper theory is needed, and nature has not yet handed us the full answer. The black hole teaches restraint. It teaches that awe is not permission to invent. The falling clock has reached the stage where imagination must become disciplined, or fail. We can follow its proper time toward the horizon. We can understand why its later ticks do not return. We can describe the external geometry, but when we ask what ultimately becomes of its complete history, we encounter the unfinished seam between relativity and quantum physics. That seam is not a weakness in the story. It is the story becoming honest. The black hole got darker because time revealed the trap. It gets darker still because understanding reveals the boundary of understanding itself. The universe has allowed us to know why the door closes, but not yet what the final room is made of. And the clock keeps falling into the part of physics still waiting for its language. A black hole has a temperature. That sentence should feel almost wrong. Temperature belongs to stoves, skin, stars, rooms, oceans, fever. It belongs to things that can be touched or sampled, things with particles shaking inside them, things that exchange heat with the world. A black hole seems to offer the opposite image, a place from which nothing returns, a horizon with no surface to touch, a silence in space-time. How can something defined by the absence of escaping light have a temperature? The answer begins with a different kind of darkness. Not visual darkness, not causal darkness, thermodynamic darkness. In ordinary life, heat is disorder made physical. A cup of coffee cools because its energy spreads into the room. Ice melts because microscopic arrangements change. A gas expands because there are vastly more ways for its molecules to be dispersed than confined. Thermodynamics is the science of that irreversible drift, hot to cold, ordered to disordered, concentrated to spread out. It is also the science that gives time an arrow. The laws of microscopic physics often allow processes to run backward in principle, but the world we experience does not behave that way. Smoke does not gather itself neatly back into a match. A shattered glass does not leap from the floor and become whole. Heat does not naturally flow from cold air into a hotter flame. The direction of ordinary time is tied to entropy, the measure of how many microscopic arrangements correspond to the same visible state. Entropy is why the future feels different from the past. And black holes, strangely, carry entropy in enormous amounts. This was not obvious. For a long time, a black hole seemed like a thermodynamic problem, disguised as an astrophysical object. If you throw a hot, disordered object into a black hole, what happens to its entropy? From outside, the object disappears behind the horizon. Its detailed microscopic state no longer remains available. If the black hole simply swallowed entropy without accounting for it, the second law of thermodynamics would appear to be threatened. Disorder could be hidden away, and the outside universe's entropy could decrease. Nature rarely permits such easy escape. Jacob Bekenstein proposed that black holes themselves must have entropy, and that this entropy is connected not to their volume, but to the area of the event horizon. That idea was radical because it treated the horizon not as a material surface, but as something that could carry thermodynamic meaning. Then Stephen Hawking's calculations gave the idea sharper force. When quantum field theory is considered in curved space-time, black holes are predicted to emit radiation with a temperature. The darkest object in classical physics began to glow in quantum theory. But this glow must be handled carefully. For astrophysical black holes, Hawking radiation is expected to be extraordinarily faint, far colder than the cosmic microwave background for large black holes, and it has not been directly observed from them. A stellar mass or supermassive black hole is not visibly evaporating in any ordinary astronomical image. Its surrounding disk may blaze, but that is not Hawking radiation. That is matter outside the horizon heating before it falls. Hawking radiation belongs to a deeper theoretical layer, where quantum fields and horizons disturb the classical meaning of emptiness. The point is not spectacle. The point is that the horizon has become thermodynamic. This changes the black hole again. It is no longer only a causal boundary. It is no longer only the place where future-directed paths from inside cannot reach outside. It becomes an object with entropy proportional to area, a temperature inversely related to mass, and a possible long-term fate, evaporation across immense timescales. Gravity, quantum theory, and thermodynamics begin to overlap in one severe structure. The black hole is not merely dark. It is hot in principle, cold in practice, and informationally immense. That combination should disturb the clean categories of thought. Heat is usually associated with matter. Entropy is usually associated with microscopic degrees of freedom. But for a black hole, the entropy seems tied to the horizon area. The boundary, the thing that is not a surface in the ordinary material sense, carries the count. The deeper theory must somehow explain what microscopic states this entropy is counting. This is where the black hole becomes a pressure chamber for physics. General relativity says the horizon is causal geometry. Thermodynamics says the horizon has entropy. Quantum theory says the horizon may radiate. Each statement has its own language, and the black hole forces those languages to refer to the same boundary. The result is not a tidy explanation, but a convergence so intense that it has reshaped modern theoretical physics. The area of the horizon becomes more than geometry. It becomes a measure of hidden possibility. Think again of the falling clock. Outside the horizon, its ticks are physical events that can still be reported. Near the horizon, those reports become redshifted and delayed. Inside, later ticks cannot send news back out. Classical relativity says the outside cannot recover the clock's detailed interior history by direct signals. But thermodynamics asks a different question. When the clock falls in, does the black hole's entropy increase in a way that accounts for the lost detail? The clock does not merely disappear. It changes the bookkeeping of the horizon. Its mass energy adds to the black hole. The horizon area grows. The entropy associated with that area grows. The outside loses access to the clock's detailed state, but the black hole's macroscopic parameters change. Something has been preserved in bulk and hidden in detail. That distinction becomes the doorway into one of the deepest problems in physics. Because quantum theory is not comfortable with the permanent destruction of information. In ordinary quantum mechanics, the evolution of a closed system preserves information in a precise technical sense. The final state may be scrambled beyond practical recovery, but the laws do not simply erase the distinction between different initial states. Black holes seem to threaten this principle. If matter falls in, and the black hole eventually evaporates into thermal radiation that carries no detailed record of what formed it, then what happened to the information? This is the black hole information problem. It is not a puzzle for curiosity alone. It is a collision between pillars: general relativity, quantum mechanics, and thermodynamics. Each has earned trust in its domain. Each speaks with authority. But inside the black hole problem, their demands press against one another until something must give, deepen, or be reinterpreted. The darkness has become epistemic. Not because science gives up, but because science has arrived at a place where its best languages disagree about what must be true. The event horizon once meant no signal returns. Thermodynamics adds that the horizon stores entropy. Quantum theory adds that horizons are not completely inert. Information theory then asks whether the complete story of what falls in is preserved, scrambled, radiated, encoded, or transformed in a way no classical picture can show. The black hole is no longer just a place in space-time. It is an argument between the deepest rules we know. And still, the emotional force must remain disciplined. This is not permission to claim that black holes are portals, cosmic computers in a literal simple sense, or gateways to convenient elsewhere. The honest force is sharper. A black hole takes the most successful frameworks in physics and makes them answer the same question at once. What is time? What is heat? What is information? What does a horizon count? What does it mean for an event to be lost from view, but perhaps not lost from the laws? The falling clock is now more than an image. It is evidence handed to the universe's accounting system. Its face fades from outside view. Its later ticks cannot return. Its energy changes the whole. Its information becomes the subject of a deeper dispute. The clock has fallen from visual darkness into causal darkness, and from causal darkness into thermodynamic ambiguity. This is the price of asking what black holes are. The answer does not stop at gravity. It reaches into the arrow of time itself. The deepest darkness in a black hole is not that light fails to return. It is that history itself seems to approach a question mark. A stone falls in, a star falls in, a clock falls in, a book falls in, every page arranged in a precise order, every ink molecule occupying a particular state. From outside, the details vanish behind the horizon. The black hole's mass may increase, its spin may change, its charge, if any, may change. But the intricate difference between a clock and a book, between one book and another, between a collapsed star with one microscopic history and a collapsed star with a different microscopic history, appears to be hidden behind a boundary that cannot report back. Classically, this already feels severe. Quantum mechanically, it becomes intolerable. Quantum theory does not treat information as casual decoration. It is not merely a human record. It is tied to the physical state itself, to the distinctions that allow one possible history to be different from another. In ordinary quantum evolution, those distinctions are not simply erased. They may become scrambled. They may become spread across correlations too complex to reconstruct in practice. They may become inaccessible to any realistic observer. But inaccessible is not the same as destroyed. A burned book is not truly erased from the universe in the deepest physical sense. Its smoke, ash, radiation, and surrounding air carry traces, however hopelessly dispersed, of the process. Practical recovery may be impossible. The laws do not care about practical recovery. They ask whether the final state still contains, in principle, enough structure to distinguish the initial one. The black hole asks whether that principle survives gravity. That is why the information problem is not a technical footnote. It is the black hole pressing its full weight against the meaning of time. If the information about what formed the black hole is permanently destroyed, then quantum theory must change. If the information is preserved, then the classical picture of the horizon as a simple one-way causal boundary may be incomplete in some profound way. If the information escapes in Hawking radiation, then the radiation cannot be perfectly featureless thermal noise. If it remains encoded on or near the horizon, then the boundary is more than classical geometry. If it hides in correlations too subtle to see, then the darkness is not erasure, but encryption by nature itself. Every answer is expensive. There is no cheap exit. This is the final destabilization because it does not merely ask what happens inside a black hole. It asks what it means for anything to have happened at all. A universe that destroys information is a different kind of universe from one that preserves it. A universe where time evolution can erase distinctions completely is not the same universe as the one quantum theory has taught us to expect. The black hole turns what fell in into, does reality keep accounts? The question sounds almost moral, but it is physical. Does the universe remember? Not in a conscious sense, not as intention, not as archive written for us. The question is whether the laws preserve the structure of states through time, whether the future contains, encoded somewhere, the distinctions of the past, whether the arrow of time is accompanied by scrambling rather than annihilation. The falling clock now becomes unbearable in a new way. Earlier, its fading pulses showed that distant observers lose access to its later ticks. Then the horizon showed that no outward signal from inside can return. Then thermodynamics suggested that the clock changes the black hole's entropy and area. But now the question tightens. Is the detailed physical identity of the clock preserved in the total state of the universe? Or does the horizon allow history to be truly deleted? The clock is not merely lost to us. It may be testing whether loss exists at the most fundamental level. This is where black holes become darker than any ordinary darkness, because ordinary darkness does not threaten the past. A room without light still contains its furniture. A cave still preserves footprints. A sealed box still holds what was placed inside. Even if no one looks, the world inside remains part of the same ordinary chain of facts. The horizon is different because what enters cannot send reports out. And if evaporation eventually removes the black hole, one must ask where the detailed interior history went. If the black hole simply disappears into radiation with no memory, then the universe has performed an act stranger than concealment. It has turned distinct pasts into the same future. That possibility is what physicists have struggled against for decades. The struggle has produced ideas of extraordinary depth, holography, complementarity, entanglement, quantum extremal surfaces, subtle correlations in radiation, the possibility that space-time itself emerges from patterns of quantum information. These are not decorative theories invented to make black holes more mysterious. They are attempts to protect the consistency of laws that have worked too well to abandon lightly. And yet none of this should be presented as a settled popular slogan. The honest statement is sharper. Black holes have forced physics to suspect that information, entropy, geometry, and space-time are not separate subjects. The horizon may be a place where the universe reveals that space itself is less fundamental than the information structure beneath it. That possibility remains an active frontier, not a completed picture for casual certainty. But even as a frontier, it changes the emotional meaning of the black hole. The darkness is no longer just a region. It is a demand placed on reality's bookkeeping. This is also why the word inside begins to tremble. In ordinary life, inside and outside are spatial relations. A coin is inside a box. A person is inside a room. A planet is inside an orbit. But if the complete description of a black hole can in some sense be encoded on its boundary, if the information associated with a volume is tied to an area, then the old spatial intuition weakens again. The black hole suggests that the universe may not store reality the way the body imagines reality being stored. Depth may not mean what it appears to mean. The horizon may not be merely the edge of a hidden interior. It may be a clue that geometry and information are entwined at a level where our ordinary categories become approximate, not false in daily life, not useless, but local, like every intuition black holes have already stripped away. The falling clock, once more, carries the whole argument. It began as an object in space, then it became a world line, then a source of redshifted signals, then a crossing event, then a private interior history, then an addition to entropy. Now it becomes a question about whether the universe permits perfect forgetting. And the answer is not yet fully in our hands. That unfinished state is not a weakness of science. It is science at the edge of honesty, refusing to turn ignorance into myth, and refusing to flatten difficulty into comfort. The black hole stands there as a lawful object, whose existence is supported by observation, whose exterior is described by powerful theory, and whose deepest implications still force the foundations to negotiate with one another. It is dark because no light returns. Darker because no report returns. Darker still because the fate of what falls in may decide what time is allowed to do to information. The clock's final lesson is no longer about vanishing. It is about whether vanishing is ever absolute. Return to the clock. It is still falling. By now, the image should no longer feel simple. At the beginning, it was only a small object approaching a dark place. A clock, a pulse, a fading light. The scene seemed almost clean enough to hold in the hand. We could imagine watching it through a telescope, waiting for the instant when it crossed some invisible edge. But that first image has been altered by everything beneath it. The clock is no longer merely falling through space. It is tracing a world line through curved space-time. Its light is no longer merely dimming. It is being redshifted by gravity, stretched by the climb from a deeper region, delayed by the geometry through which it must travel. Its slowing is no longer a defect in the clock. It is a disagreement between paths, between proper time and distant time, between what the falling object carries with it and what the far universe can receive. The horizon is no longer an edge. It is the last address from which later light can still reach home. So look again, but more slowly. A pulse leaves the clock. It climbs. It arrives far away, weaker than it was, redder than it was, later than expected. Another pulse follows. It takes longer. Another, longer still. The rhythm stretches until the clock seems less like an object moving through darkness and more like a voice being pulled out of language one syllable at a time. Nothing has to explode. Nothing has to strike a surface. The drama is not impact, it is disconnection. The outside universe receives older and older versions of the clock, each one closer to the boundary, each one carrying less energy, each one arriving after a longer silence. The clock's image becomes a memory that refuses to finish. The crossing is not delivered as an ordinary scene. There is no final frame in which the distant observer sees the clock pass through and vanish. Instead, the clock becomes increasingly red, increasingly faint, increasingly delayed, until practical observation loses it to darkness. But practical loss is not the deepest loss. Past the horizon, later events in the clock's history are no longer part of the outside's reachable future. The clock may still tick locally. It may still have moments, if moments are counted along its own path. It may still encounter the interior future written by the geometry. But its later ticks cannot become messages to distant stars. The universe outside does not merely fail to see them. It is not among their possible recipients. That is the transformed meaning of the opening image. At first, the clock seemed to vanish because black holes are dark. Now the black hole is dark because vanishing has become causal. This distinction matters because it prevents us from mistaking the black hole for a spectacle. The most important thing happening to the clock is not what a distant eye fails to watch. It is the change in membership. Before the horizon, the clock belongs to a shared world of exchange. Its ticks can still enter the common future. After the horizon, its future narrows away from ours. The clock remains inside reality, but no longer inside the same communicable reality. That sentence should feel heavier than destruction. Destruction can leave debris, ash, heat, radiation, sound, shock, witness. A destroyed thing can still testify by what it becomes. The black hole's horizon is colder than that. It does not necessarily destroy at the boundary. It separates. It permits continuation while cutting off report. The falling clock is not swallowed like food. It is translated into a silence the outside cannot decode by waiting. Even the surrounding brightness changes meaning now. The accretion disk, the jets, the bent light, the glowing plasma, the intense radiation from matter outside the horizon. None of these are contradictions of blackness. They are the last public signatures of matter, not yet beyond the causal cut. They are the fire at the edge of a silence. They tell us where the geometry becomes extreme, where energy is being converted, where gravity is doing visible work. But they do not illuminate the interior. The brighter the surroundings, the stranger the center becomes. A black hole can make the universe shine around a place that gives no later answer. This is why time had to be included. Without time, the black hole remains a dark location. With time, it becomes a transformation of possible futures. Without time, the clock merely approaches an edge. With time, the clock signals thin into an asymptotic archive for one observer, while its own proper time carries it across. Without time, the horizon looks like a boundary in space. With time, it becomes a boundary in what can still happen to us. The hyphen matters. Events inside can happen. They cannot happen to us in the causal sense. They cannot arrive, announce, warn, explain, or show. They cannot become part of the outside universe's future except through the black hole's external parameters and whatever deeper quantum accounting nature finally permits. The clock has moved from visibility into inference, from inference into theory, from theory into the unfinished seam between gravity and quantum information. Its fall is no longer only a fall. It is a test of how reality preserves, hides, scrambles, or seals the facts of what occurs. There is no need to decorate this with fantasy. The real version is already severe enough. A clock falls through a boundary that is not a surface. Its light fades not because its story has ended, but because the routes by which its story could reach us have ended. The outside sees an object becoming old news. The clock, in its own frame, continues into a future the outside cannot share. The equations allow both statements to stand, and the mind has to surrender the need for one simple picture. That surrender is not defeat. It is the beginning of seeing the black hole correctly. Not as a monster, not as a hole in the childish sense, not as a cosmic drain, not as a visual absence, but as a region where the meaning of outward, future, signal, knowledge, and disappearance has been changed by space-time itself. Return finally to the last visible pulse. It is weak, it is red, it is late. It has traveled through curvature, through delay, through the widening gulf between the clock's path and the observer's. It reaches the telescope not as the present of the clock, but as a relic of a relationship that is almost over. Then the next pulse is weaker. Then the next. The silence does not slam shut, it accumulates. That is the black hole's most honest darkness, not a curtain falling, but a conversation losing all possible replies. The clock does not leave reality. It leaves the part of reality that can still speak back to us. And once that is understood, the opening image cannot be recovered in its innocent form. A clock falls toward a black hole. What falls with it is the idea that darkness is something the eye can understand. The clock is almost gone now. Not gone in the simple way objects vanish behind distance. Not gone like a ship beyond the horizon of an ocean, where another observer in another place might still see the mast, the deck, the lamp at the stern. Not gone like a candle blown out, leaving smoke and heat and chemical traces in the room. Not gone like a voice fading down a corridor, still moving through air, still recoverable if someone runs fast enough toward it. This is a colder kind of departure. The clock's last visible light reaches the outside as a weakened remnant of an earlier moment. Its face, if it can still be called a face from this distance, is no longer white or silver or clear. Its signal has been stretched until color itself has nearly given up carrying the message. Every tick arrives carrying more delay than rhythm. Every pulse is less an announcement than an afterimage. The outside waits. The clock continues. Between those two statements, the black hole opens. This is the place where the mind wants a final scene and does not receive one. No clean disappearance, no last frame, no impact against the surface, no dramatic instant in which the object touches the edge of darkness and is erased. The universe refuses that theatrical mercy. It gives instead an asymptote, a thinning, a red wound in the signal, a silence that grows not because time has stopped everywhere, but because the route from that future to this one has been severed. The black hole is darker than the eye can mean by dark. It is dark in the old sense, yes. No classical light from inside the horizon escapes to distant observers. But that sentence is now too small to carry the weight. The deeper darkness is not made of photons failing to arrive. It is made of futures that cannot meet again. It is made of causal paths that close inward. It is made of a clock that may still have moments, while those moments no longer belong to the outside universe's possible news. The horror is quiet because nothing needs to be added. No monster waits at the boundary. No mouth opens. No cosmic appetite explains the loss. The horizon does not hate light. It does not reach outward for the clock. It does not perform darkness. It is simply the place where the geometry of space-time has become severe enough that outward tomorrow is no longer among the allowed directions. That is why black holes are not less strange when understood. They are stranger. The crude mystery was easy, a thing so dense that light cannot escape. The mature mystery is harder, a region where time, causality, thermodynamics, and information are forced into the same question. The crude image gave us a dark object. The deeper image gives us a boundary, where the universe decides which events can still become part of another event's future. And this boundary is not an error in reality. It is reality behaving lawfully. That may be the most unsettling part. A black hole does not represent a failure of order. It is not chaos winning. It is not physics tearing apart into nonsense at the horizon. The event horizon is a consequence of rules that also govern clocks, planets, light, orbits, and the large-scale structure of the cosmos. The same universe that lets your hand catch a falling glass also permits a horizon from which no later interior event can speak outward. The familiar and the impossible-looking belong to one law. Human intuition cannot live comfortably there because human intuition was born in mercy. Weak gravity, slow speeds, stable ground, shared mornings, clocks that agree well enough for meals, work, grief, sleep. We evolved in a thin, forgiving region of the possible, and from that region we built words like now, here, away, before, after, inside, outside. The words are not useless. They carried us far enough to discover where they begin to fail. A black hole is one of those places. It does not merely add a new object to the inventory of the universe. It subtracts confidence from the old inventory. Space is not just the room. Time is not just the clock. Darkness is not just the absence of light. Seeing is not the same as knowing. A boundary is not always a surface. A future is not guaranteed to remain shared. The clock taught all of this by disappearing badly. A clean disappearance would have spared us. If the clock had simply blinked out, the mind could file the black hole among destructive things. Fire consumes, oceans drown, stars explode, black holes swallow. But the actual lesson is less primitive. The clock fades because its messages are stretched. It appears to slow because time is not universal. It crosses because its own proper time carries it forward. It stops reporting because the horizon has cut the outward route. It leaves us not with an image of annihilation, but with the structure of separation. The clock does not teach that everything ends. It teaches that not every continuation remains ours. Somewhere beyond the last received pulse, in the classical description, the clock's interior future points toward a region where the theory itself will eventually demand something more than classical space-time. Perhaps a deeper quantum theory preserves every distinction in a form not yet fully visible to us. Perhaps the horizon's entropy, radiation, and information are clues that space-time is woven from something more fundamental than geometry alone. These possibilities should not be turned into easy myths. They are not escape hatches for imagination. They are signs that the question is real enough to resist simple language. The black hole does not invite fantasy. It punishes imprecision. And still, even with discipline, the image remains haunting. The clock falls, the light reddens, the intervals widen. Around the black hole, gas may burn bright enough to announce itself across cosmic distances. Stars may whip around the unseen mass. Gravitational waves may carry the memory of mergers through space-time. Telescopes may gather arcs, shadows, spectra, timing, evidence. The universe may reveal everything it can reveal from outside. At the center, the horizon gives no later reply. That silence is not emptiness. It has mass. It has geometry. It has entropy. It can grow. It can spin. It can merge. It can bend the paths of light and shape the behavior of galaxies. It is not nothing. It is a presence defined by what cannot come back. The clock's last pulse is almost indistinguishable from darkness now. Perhaps no instrument will recover the next one. Perhaps the signal has fallen beneath noise, beneath practicality, beneath the patience of any observer. But the important loss has already happened in the mind watching it. The old image of the universe has crossed its own horizon. There was a time when darkness meant something simple. A room without a lamp. A night without a moon. A distance between stars. Then the clock fell, and darkness became a geometry of no return. It became redshift and delay. It became the narrowing of possible futures. It became the silence of interior events. It became the question of whether the universe preserves what it hides. It became the edge, where knowledge remains rigorous and incomplete at the same time. The black hole has not become darker, like a surface painted blacker. It has become darker because time has entered the meaning of darkness. The clock is no longer visible. But the final image is not of a thing destroyed. It is of a lawful universe, calm enough to let a clock keep falling, and severe enough to remove its future from ours. At the horizon, light does not merely fail to escape. Outward, tomorrow disappears.